Imagine a place in our solar system, beneath the icy surface of a distant moon, a hidden ocean that might be full of life. Here is Europa, one of Jupiter's moons, which scientists consider one of the best places to find extraterrestrial life. But if we could travel there, what would we see? Are there living creatures in the depths of this dark ocean? How can we pass through the thick ice and uncover the secrets of this unknown world? In this video, we will travel to Europa and explore the possibility of life there. So join us. Jupiter has many moons orbiting around it, but the largest and most important ones are known as the Galilean moons. This name was given to them because Galileo discovered these moons in 1610. Initially, Galileo thought these objects were fixed stars in the sky, but with further observations he realized their behavior was different from stars. He found that these objects were actually orbiting Jupiter and were its moons. The four famous moons of Jupiter, known as the Galilean moons, are Io, Europa, Ganymede, and Callisto. This moon of Jupiter is the smallest Galilean moon and is slightly smaller than Earth's moon. The surface of Europa consists of a layer of water around its mantle, with the upper part being solid ice and the lower part believed to be liquid water. Scientists, after analyzing images sent by the Galileo spacecraft, discovered that this moon has an iron core and a rocky mantle made of silicate rocks. In this way, it shares some similarities with Earth. But the main difference with Earth is that, unlike our planet, Europa's rocky layer is covered by about 100 kilometers of ice. Scientists predict that beneath this icy shell, there is a vast ocean of liquid water. This possibility has made Europa one of the most important targets in the search for extraterrestrial life, attracting the attention of many researchers. Interestingly, sometimes water from this hidden ocean erupts like volcanic lava, creating icy mountains on the surface of the moon. For example, in 2013, the Hubble Space Telescope recorded eruptions of water vapor at Europa's South Pole. This phenomenon disappeared after a while, which may indicate a cyclical process in Europa's subsurface activity. Now, let's answer this important question. Can we live on Europa? The short answer is that there is hope, but the challenges are many. One of the main reasons for hope is the presence of liquid water. The ocean beneath Europa's icy shell may contain nutrients and organic compounds necessary for life to form. These conditions might be suitable for microbial life or simple organisms, but there are significant challenges for human life. For example, Europa's ocean could be a valuable source of water, but extracting it from beneath a thick ice layer, several tens of kilometers deep, would not be easy. In addition, the extremely low temperatures, the lack of a breathable atmosphere, and the intense radiation from Jupiter pose major barriers to establishing a human base on this moon. However, researchers are still studying this moon because if extraterrestrial life exists in our solar system, Europa is one of the best candidates to find it. Another reason for hope in the existence of life on Europa is the presence of essential chemical compounds for life. In Earth's oceans, in addition to water, compounds such as salts, minerals, and organic compounds are found, which are essential for the growth and nutrition of living organisms. Studies and observations show that Europa's subsurface ocean might contain similar compounds. Studies indicate that similar compounds might be present in Europa's subsurface ocean, such as minerals and salts, because the data suggest this ocean is salty, and organic compounds, like carbon-based ones. Another factor that increases hope for life on Europa is the source of energy. On Earth, the energy we need mainly comes from the sun. However, on planets and moons that are far from the sun and receive little light, a type of life known as chemoautotrophs, can survive. Chemoautotrophs are organisms that do not need sunlight to obtain energy. Instead, they use chemical reactions between minerals to produce food and grow. Where can they be found? In the depths of Earth's oceans, where sunlight does not reach. Near hydrothermal vents on the ocean floor, where underwater volcanic activity releases chemicals. In environments rich in sulfur and iron compounds, which provide the necessary energy for these organisms' metabolism. Why is this important for Europa? If volcanic or thermal activity exists on Europa's subsurface ocean floor, it could create an environment similar to Earth's deep oceans. In this case, chemoautotrophs could use chemical energy to survive without the need for sunlight. This theory suggests that even in Europa's complete darkness, microbial life could still be possible. Europa has a very thin atmosphere, mostly made of oxygen. But this oxygen is not breathable for humans. This is because Europa's atmospheric pressure is so low that it is almost considered a vacuum. The oxygen present in Europa's atmosphere is much less dense than the levels needed for human respiration. This oxygen is produced by the breakdown of water molecules due to intense solar radiation and Jupiter's radiation, but it is not suitable for human breathing. Unlike Earth, Europa does not have any weather such as wind or rain because its atmosphere is too thin to create dynamic weather conditions. Europa's surface temperature is about minus 160 degrees Celsius. This means living there without special equipment is absolutely impossible. The Galileo project, which started in 1989 by NASA, provided a vast amount of information about Jupiter and its moons, including Europa. After that, the attention of scientists to research on this moon has increased day by day. Data sent from the Hubble Space Telescope and the reanalysis of the Galileo spacecraft data show that eruptions from Europa's subsurface ocean rise as high as 160 kilometers above its surface. Now the question arises, is Europa more suitable for life than Mars? This is a question that has been worked on. If we are looking for the best place to find life in the solar system, Europa and Mars are both attractive options, but they differ in many ways. Mars, with its thin atmosphere and signs of liquid water in the past, is a good candidate for human settlement in the future, but its dry and radioactive surface makes life challenging. On the other hand, Europa has an icy surface, but beneath this ice, a vast ocean is hidden that could provide a suitable environment for microbial life. If our goal is to discover life, Europa is the better choice. But if we are looking for a place to settle, Mars is currently the more feasible option. If these geysers truly exist, they would allow spacecraft to sample materials from Europa's subsurface ocean without drilling. If this is confirmed in future exploratory missions, it is likely that the origin of the geysers is a large, salty ocean hidden beneath Europa's icy surface. In any case, this ocean is already one of the most exciting and fascinating locations for astronauts. And interestingly, steps have already been taken to explore this. The Europa Clipper mission, launched by NASA, aims to study and investigate Europa in detail. This mission is designed to gather information about Europa's environmental conditions and answer the key question: can this icy moon support life? The Europa Clipper spacecraft was launched on October 14, 2024, by SpaceX's Falcon Heavy rocket from NASA's Kennedy Space Center. On its way to Jupiter, the spacecraft will pass Mars and use the planet's gravity to gain speed for its journey toward Jupiter. According to NASA's plans, Europa Clipper is expected to reach the Jupiter system by 2030. After reaching Jupiter's orbit in 2030, the spacecraft will make more than 50 close flybys of Europa to examine the conditions of its subsurface ocean. The spacecraft will scan Europa's icy surface, analyze its chemical composition, and search for possible signs of life. It will also check if water is erupting into space through cracks in the ice. The data from this mission will help us determine if Europa has the right conditions for extraterrestrial microbes. Europa Clipper is set to become one of the most exciting space missions in history. This spacecraft will travel to one of the best places in the solar system to search for extraterrestrial life. Does Europa's hidden ocean hold secrets for us? Will we find signs of life there? Europa Clipper will give us definitive answers to these questions.